Okay, so this is my master's project. I'm currently looking at taking palaeo-colour above the individual specimen or species description level. So melanosomes preserve coloration or pigmentation patterns in extinct taxa, and we use those to infer their ecologies. However, this has previously only ever been kept to single species or specimens, and whilst it's great to know what one dinosaur or one bird looked like, it doesn't really tell us that much about the overall ecosystem. So we want to take it onto that level. And the Bolca fishes represent a very understudied ladder-starter from northern Italy from the early Eocene. And they are important to understand because they're the first acanthomorph-dominated marine system we've ever encountered. And acanthomorphs represent the majority of modern taxonomic diversity in analogous systems. So it'd be quite nice to understand their ecology, and pigmentation is rife amongst them. So we want to utilize pigmentation reconstructions to test the hypothesis that the Bolca fishes represented a shallow marine system analogous to modern Indo-Pacific reefs. So the methods to this are quite simple and easy to understand. I've been journeying around Europe, going to nice museums and photographing their collections, and I've been using polarized and UV light technologies to better highlight the preserved melanosomes and make them more visible against the surrounding matrix and other biomineralized tissues. So there's a great diversity of patterns preserved within the Bolca fishes, and these range from nice spots and stripes, even coloration gradients, to ubiquitous coloration on flatfishes where the water exposed side is nice and dark and the side pressed against the sediment is generally a lot lighter. And really this is when it starts to get interesting, because you can take some really quick and nice big qualitative conclusions from this. So first and foremost, we have the diverse range of pigmentation patterns that are preserved within this assemblage. Secondly, these pigmentation patterns are seen within extant taxa, so you can start to assume that the same communicative signals are being used throughout the Cenozoic, and that this is quite important because it's happening across a number of systems. But when you take this collectively and start asking what kind of ecosystem this was, spotty and striped fishes don't generally live in open water systems. They're quite conspicuous to predation and often get taken out. And because of the giant abundance of spotted and striped and effectively brightly patterned fish present, we can start to refute the idea that this would ever be an open water setting. And whilst we can't currently talk at a qualitative standpoint as to whether or not this is analogous to modern coral reef systems, we're hoping to use quantitative analysis to do this. So future study will focus on modern systems and database entries and a PCA analysis of the relative abundances of each fish pigmentation type. And hopefully we'll see what it clusters with and be able to take a more specific inference about its ecology from that. So does it cluster with shallow marine environments such as Indo-Pacific coral reefs, as we think it will do, or will it cluster with mangrove forests and such like that? So really all I want to conclude is that from looking above a single specimen or a single species, we can take some bigger inferences about the ecology of ecosystems, and we can do that very quickly, qualitatively, and hopefully we can make this much more specific and with higher fidelity and accuracy using quantitative statistics in the future. It would be nice to stop using it simply to make pretty pictures. Has anybody got any questions?